then we have 3s, 3p, 4s, 3d, 1, 2, 3, 4, 5. And then we have the 4p, 1, 2, 3, 4p. So let's put the electrons in. I just want to show you something with this. Okay, so that's krypton. What do you notice about it? It's all complete. So every single orbital have the maximum amount of electrons that it has. And this is why krypton is the most stable element. Because this is the lowest energy it can have. It doesn't want to give away electrons. It doesn't want to add in any electrons. And this is why it is stable. And that's true for all of these noble gases. So all of these noble gases have their orbitals completely filled in, and that's why they are stable, because their orbitals are completely filled in. Okay? And the other elements want to become like them. They gain or lose electron because they want to have a completely filled up orbitals, because that's what makes them stable. So if you look at iodine, it is 1 electron away from the element in front of it, which is xenon. So here we have xenon. So iodine, when it's going to react, it's going to add an electron. That's why it's I-1. So it becomes like xenon. So it have the same amount of electrons as xenon. Same thing for chlorine. So chlorine has argon next to it, and then it's going to add in 1 electron to become like argon. If you have, for example, oxygen, it needs to add in 2 electrons to become like neon. So that's why it's a -2. Now it could actually, if you have oxygen here, it also can lose 1, 2, 3, 4, 5, 6 and become like helium. But it's easier to gain 2 than losing 6, because 6 is a bigger number. So that's why oxygen will gain and become like the noble gas in front of it. If you take something like, for example, lithium, which is right here, it is easier for lithium to lose 1 electron and become like helium rather than gaining 7 and becoming like the neon. So this is why Li would lose 1 electron and become Li plus. So always the elements lose or gain to become like the noble gas the closest to them. This is why we have all group 1 is 1 plus, all group 2 is 2 plus, and so on. Because remember, previously I told you, you just have to know that. You just have to know all of these are plus and all of, but now we know just because they want to become like the noble gas closer to them. So that's why they do lose 1 or 2 or 3, depending on their location or how many electrons they have.
So if the noble gases, like you can use them as a brief